All right, April 26, 2012, Chapter 4 review. It's essentially quadratic functions and many different things that you can do with them. Solving them, finding x-intercepts, vertex form, all those things. So, from lesson 4.1, we talked about vertex form. And one of the review questions is to look at a graph and write the equation of this function. So, they've told us they want us to write this in vertex form. Let's bring up our formulas on the side here. Okay, so we brought up our formulas here. This is our vertex form, which is our a bracket x minus h squared plus k. So we'll bring down a version of that.
A bracket x minus
okay. So we have our vertex form. Let's zoom in a little. And what we're going to need to do is essentially determine where the vertex is on this parabola. So what point is the vertex at on this parabola?
Negative 5 and 6.
Yeah. Negative 5 and 6. Now, in terms of our vertex form, what variables do those two numbers stand for?
H and K.
Okay, so we have our h and our k value. So we're going to go plug those in. So if our h is negative 5 and our k, negative 5 and 6. Okay, so we have hk values. We go to plug them in. Y is equal to a. Our x value is what? No, it's still just x. Right? We're not plugging that number in for x. We're plugging in for... That was a trick question. We replace h with our negative 5. This is our h value. This is our k value. Squared plus positive 6. Okay? Those signs in the formula, this negative and this positive, need to be there. Okay? That's why we end up getting kind of a reverse inside the brackets, and this one stays steady. It's because it's a positive sign. So we go to simplify that. We get y is equal to a, x plus 5 squared, and then plus 6. Now, we got to find our a value. In order to do that, I need to pick a point along the rest of the parabola. What would be a good one to choose?
Negative 7 and 4.
0 is in between. We don't exactly know where this is. But right here, yes, we have negative 7 and 4. We can use that point there for our x and our y values. So let's plug those in. Negative 7 and 4 are going to go in for x and y. So instead of writing in y, we write in what? 4 is equal to? Plus 6. Okay. And now what's our goal? Solve for a. That's right. So we use our bedmass, solve what's in the brackets, gives us negative 2 squared is 4. We're going to get 4 is equal to 4a plus 6. When I move 6 over, what does it become? Negative 6.
Negative 2 equals 4a.
Very good. You guys are flying through this. We divide both sides by 4. A is equal to what?
Negative 0.5.
1 over 2 or 0.5. So the goal was to find the equation. Our final equation is written as y is equal to either negative 0.5 or negative a half, either acceptable. X plus 5 plus 6, and then same idea, x plus 5 squared plus 6. So I know we kind of just ran through that, but you guys have done that before from the last chapter. It's the beginning of this one also. Okay, we have a question here. Call it example 2. Anyone know what form this question's in? That's right. This is in standard form. Okay. The question says it wants us to put us into vertex form. Okay. Now, luckily in the question, it tells you what you use to go from standard to vertex form. Anyone know what it's called? We complete the square. Good. So to go from standard to vertex, complete the square. You guys might want to write this one down. There's also another form we use, which is factored form. What do I do to go from standard to factored form?
Factor.
That's right, we factor. Very simple. Okay. What about to go from vertex to standard.
You try to put a.
No, you just foil it, yeah.
Expand and simplify. Yeah, we foil, or are gonna call it's called expanding and simplify. Okay. What about to go from vertex? Actually, hold on. Let's go from factored to vertex form. What would I use?
Quadratic.
Well, quadratic's going to tell us exactly what the x-intercepts are, which is what factoring does.
Yo, you use the zeros.
We use zeros, and what do we do with them?
Oh, you meant the vertex.
We got to find the vertex. So using the zeros, how do I find the vertex?
You separate them, right? You separate the zeros. And you plot them on the x-axis.
AOS.
Yeah.
We use our x-intercepts. We're going to find out our axis of symmetry. Okay, so AOS, axis of symmetry, and then what do we do?
With the axis of symmetry, you put it into the x, and then you get your equation.
Plus, plug in.
I'm still gonna be.
And finally, so you find the AOS by adding your, this is our formula over here. Yeah, we add the two zeros, divide by 2, gives us axis symmetry. Then I put plus plug in, so we plug that in. And then what about if I wanted to go from, let's say, vertex to factored form?
You expanded the thing in the brackets.
Well, wouldn't you put it into standard form? You put it into standard form and factor.
What does factored form tell us?
It's factored.
What is what parts of the equation does it help us find? X's.
Yeah.
Zeros. That's very important. What is set equal to 0 when we're finding zeros? Y. So to figure out what the zeros are, and we plug 0 in for y. Okay. So to go from here, plug 0 in for y.
That's easy as hell.
And sorry, the last one we didn't do. It's actually quite straightforward. Go from factor to standard. What do we do? Expand and simplify.
Yeah.
Same thing. So to go from vertex or from factor to standard, we use the same style. Okay? And there is a little side note. If we're unable to factor from standard form, if I can't factor, so this is if can't factor, what do we use?
Quadratic.
Yes. If we can't factor, we use quadratic formula. Oh, that's a lot bigger than that was. We'll put it down here. Okay? So after that long explanation, it's kind of a flow chart here. The goal was to take this standard form and turn it into vertex form, which we know we need to complete the square to do. So we're going to move to a new page here. All right, so we're in standard form. We need to get to vertex form. Completing the square. Very first step to completing the square, what do I do?
Divide by something. Divide the first two by 2.
Divide the first two by, what's the letter they use for it?
2.
A. It's usually called the A term, right? It's the term in front of the x squared. So it's 2 in this one, just like they said. So we divide the very first two terms by that number. That number comes to the outside of the brackets.
You don't divide by 2x squared, you divide by 2.
Just by 2. The reason doing this is because we want x squared to have a coefficient of 1. Okay? So that's what happens. We take the 2 out of the first two terms because we want to have a coefficient of 1 in front of x squared. Now once we do that,
You gotta bring B over there and do your like little.
yeah, we have a b. The formula looks like this. We have this little formula, b divided by 2 squared. What is our b term?
X.
1. There's a 1 in front of this. So 1 divided by 2 gives us a half squared.
0.5.
This is either 0.5.
0.25.
It is either 0.25 or if we square a fraction or multiply a fraction, so this is a half multiplied by a half, it gives us 1 over 4. Now, I want to use 1 over 4 because I want to show you how easy this can be. You won't not need to use a calculator. Using our decimals, I would assume most of you guys needed a calculator to multiply that, or you wanted to because it's fast. I'm going to use the fraction because I'm going to show you how fast this really can be. Remember, we have to add and subtract that number inside those brackets. So, we'll move this over a little. We're left with 2x squared plus x plus a quarter minus a quarter plus 4. Now, we need to move which? Negative a quarter to the outside. And what do I got to multiply when I do it by?
2.
Our a term. When I multiply that, we get 2x squared plus x plus a quarter. What does it become when we multiply? A half. When we're multiplying fractions, this is 2 over 1 times 1 over 4. It gets 2 over 4, which is a half. Okay? So essentially, think of it like this, plus 1/2. I didn't really need a calculator for that.
It looks so much easier if you just did it in decimal.
Just wait. Now, here's the very easy part. This is why it becomes super easy to do this. Remember I said the fast way to figure out or factor our brackets is to find the square root of the first and last term. Square root of x squared, really easy. It's just x. Square root of 1 over 4. Now, it may seem confusing, but I want you guys to think of it like this. What is the square root of the top term? What's the square root of 1?
1.
Okay, so we got that.
1
1 over, what's the square root of 4?
2.
There it is. We square root it very easily without using a calculator. Okay, so we now take those terms. We have 2, and remember we now combine this into one bracket squared. Our first term is the x, our second term is the half, and we bring down the positive sign. And then what is, in decimal form, what is 4 plus a half?
4.5.
4.5. Or 4.5. And that's it.
Oh,
That will be in the vertex. Okay, lesson 4.6. This is a water fountain, and we took snapshots of where the water was in the air when it was being sprayed. So we have several points of data. I need to create an equation. Okay? Create an equation. And it needs to be in standard form, okay? Now, it is, I personally cannot put this by looking at it directly into standard form. I need to work through one of the other forms we have. Now, yesterday we talked about which form? Vertex. I can use vertex form, and I can estimate the vertex. What would you guys say the vertex of this is at, roughly?
Probably 6, 4.5.
I even might think it's right in between here. I might even estimate at 5 and 5 for the vertex, right? So that would be great for vertex form. But let's say I wasn't very good at estimating. I was a little unsure. What other form and points could I use?
Factored for
Zeros. So one of the zeros might be here at 1 and 0. And the other one looks like it could be at 9 and 0. So we have options. We can use either our vertex or our factored form to solve this. Now remember, because this is data, it won't be perfectly drawn, and our numbers won't be exactly the same, but they should be relatively close when we go through this. So we're going to test these out. We have our factored form we'll put over here. So we'll do this side in factored, and we'll do the other side in vertex form.
Eat it.
So, our vertex for our vertex form was at 5 and 5. And our two zeros for factored form were at 1 and 0 and 9 and 0. So, let's work on plugging those in. Now, we've already done one with vertex form. We already have an idea that this is going to be the h and the k. So, when we go to put this in, we'll get y is equal to a, x, minus positive 5, so it becomes a negative 5, and then plus 5. In our factor form, the r and the s are the actual x-intercepts. So again, there are negative signs in front of them, so it becomes x subtract 1 and x subtract 9. Okay? Now, we have a lot of information in both. We still need to solve for what variable in both equations? A. I need to find the a in both equations. What two variables can I gather information about? X and y. I'm going to grab a point. What point should we get?
2 and 2.
Yeah, I guess we can estimate that's roughly 2 and 2. So we'll say at 2 and 2, is going to be our x and our y. So we're going to replace y with the number 2 here is equal to a, x minus 5 squared plus 5. And in the other one, oh, very sorry. Thank you.
It's okay.
So you use the 2 twice in the other one?
Yes. So that one of them replaced our y, and the other 2 replaced our x. In this one, y is 2, a, and x is 2. So it's going to replace both x's with the number 2. So we get 2 subtract 1 and 2 subtract 9. Okay? So let's try to work this out here. 2 is equal to a, negative 3 squared plus 5. We'll do one step at a time. 2 is equal to a, 1 times negative 7. Okay. And then this one becomes 2 is equal to 9 plus 5. Here we get 2 is equal to negative 7a. Factor form looks like it's going to go a little faster. In our other one, we're going to bring the 5 over. So we bring the 5 over, what are we going to get here? 2 subtract 5 is equal to a by 9. And in this one, it becomes 2 over negative 7. That's going to be our a value. In this one, we're going to get negative 3 over 9 equals a. Okay, so these fractions are different. Right? Remember we said they won't be exact. Let's get an idea of how close they are. Hopefully we estimate it well while doing this. 3 divided by 9, 0.333. Sorry, negative 0.3 repeated. And again, negative divided by 7, 0.28. So a little off, but again, because we're estimating numbers here, what we're going to do is we're going to round to the nearest tenth. And when I round these to the nearest tenth, what will both become?
0.3.
Negative 0.3 is approximately a, and negative 0.3 is approximately a. So, though we went through different roots and got slightly different numbers, when we round it, we end up with roughly the same a value. When you do a question like this, I don't expect everyone's to be the exact. As long as you estimate it appropriately, like you use numbers that seem logical, then your answer, if everything's worked out, would be fine. So, in both examples, our final answer is going to be, oh, sorry, this is in vertex, y equals negative 0.3, x minus 5 squared plus 5, or y equals negative 0.3, x minus 1, x minus 9. Okay? Now, what did it finally say we had to do in this question? What was the goal? What form? Standard form. Okay. Now again, our numbers are a little different. We'll see if our standard forms end up working out. It should be roughly the same here. Y equals, we're going to have to FOIL that, negative 0.3. Now when I FOIL this, I'm going to get x squared. Anyone know what the middle term is going to be?
Minus 5 plus 5.
Minus 10.
Minus 10.
Plus 25.
Good.
Oh, you're just doing it faster. Right?
Yeah. Jumped ahead. Okay. And in this one here, when we go to FOIL it, y equals negative 0.3, x squared. What's this one going to be? Middle term, anyone know?
Negative x, 1 plus 1. No, negative 1x. Negative 9x.
Okay, negative 9x minus x plus 1. All right, so we're jumping ahead. Negative 0.3. This, when we multiply it in, becomes x squared. This becomes positive, anyone know? 3x. This one becomes negative 7.5 plus 5, I believe. Yeah. When we simplify inside of the other bracket, negative 0.3 x squared minus 10x again, plus 9. And we'll have to FOIL. We're going to simplify the other side, negative 0.3 x squared plus 3x minus 2.5. And this one we get y equals negative 0.3 x squared plus 3x. This one will be a little different, 9 times 0.3, 0.27. Okay? Negative, sorry, 2.7. So, again, remember because we estimated a little differently, the only thing that was different, what was different looking at these? And what does that last digit stand for?
The Y.
Y-intercept. Our y-intercept was a little bit lower than our y-intercept in the first one. Okay? Like I said, they won't be exact, but they're very similar to each other.